Welcome back to the deep dive. I want to start today with something most of us probably do 5, maybe 10 times a day without even thinking about it.
Oh, yeah.
You pull out your phone, you open a travel app or maybe just Google, and you type in a sentence in English, and boom, it spits it out in Spanish or French or Japanese.
It feels like magic, doesn't it? It's like the universal translator from science fiction is finally here.
It really does.
Hmm.
But we forget that the only reason that magic works is because these companies have spent decades feeding computers millions upon millions of sentences.
Right. They have mountains of data to teach the machine.
Exactly. For English, Spanish, Mandarin, these are what you'd call high-resource languages. The AI has, virtually infinite textbooks to study from. But here's the question that got me hooked on today's topic. What happens when you try to teach a computer a language that is incredibly complex, ancient, and honestly, the computer has basically nothing to study?
A blank slate.
A total blank slate.
Yeah.
No massive digital library.
Well, that's really the frontier of natural language processing. And today, we're looking at a specific case study that tackles this head-on. It's a research paper by Loganathan Ramasamy and Zdeněk Kyburkrutsky from Charles University in Prague.
And what they did was they decided to try and teach a machine to understand Tamil.
Right. And Tamil isn't just a minor dialect. It's a classical language spoken by millions of people, mostly in South India and Sri Lanka. But for a computer,
It's a nightmare.
nightmare is a strong word, but
Mathematically,
yes, it's extremely difficult. And the paper sets up this incredible showdown.
it really does.
It pits two completely different philosophies of AI against each other to see which one can crack the code of Tamil syntax.
It's basically law and order versus street smarts. In one corner, you have the rule-based approach, teaching the computer these very strict grammatical laws.
And in the other corner, you have the corpus-based approach, just throwing raw data at the machine and telling it, you figure it out.
And the real kicker, they had to build that textbook for the computer from scratch because one just didn't exist.
Exactly.
So before we get to the robot wars, we have to understand the battlefield. I was reading through the background on Tamil in this paper, and I'll be honest, my head started to hurt. Why is this language so much harder for a computer than, say, English?
It really comes down to the fundamental architecture of the language. Tamil is a Dravidian language, which is a totally different family from the Indo-European one that English belongs to.
Okay.
And the first big hurdle is something called agglutination.
Agglutination. It sounds like something that happens to your blood.
It does sound a bit medical, doesn't it? But linguistically, it just comes from the Latin for gluing. In English, we like our words separate. If I say in the flower shop, that's 4 distinct words.
Right. 4 bricks in a wall. Easy to count.
Exactly. In Tamil, you don't stack bricks. You smash them together into one super brick. You glue the suffixes onto the root word to change the meaning. The authors use the example okatai.
Kukatai. Okay, to me, that just looks like one word.
To computers seeing it as text, it is one string of characters. But functionally, it's a whole noun phrase meaning flower shop.
Wow.
And it gets even crazier with verbs. In English, we say, he read. 2 words, subject, verb. Simple.
Sure.
In Tamil, that entire idea can be fused into a single word. And the tag, the code the computer uses to identify that word, is terrifyingly dense. The paper lists a tag for a single word that looks like this. MVPST 3 is middle F.
Whoa, hang on. MVPST 3S metal F. That looks like a generated Wi-Fi password.
Yeah.
What is a computer supposed to do with that?
Well, it's not random. It's like a zip file of meaning. MV is for main verb, PST is past tense, 3SM means third person singular masculine, and F means it's a finite verb.
So that is a lot of information packed into one block.
Exactly. So the computer can't just look for the word he to find the subject because the he is melted into the verb itself.
Okay, so that's challenge number 1, but you said there was a second one.
Right, the second boss fight,
Yeah.
word order.
This part I remember from school. In English, order is everything. The dog bit the man is news. The man bit the dog is a very different news story.
A much better one. Yes, English is SVO, subject, verb, object. If you swap them, the meaning changes. Tamil is different. It's strictly head final, which just means the main verb has to sit at the end of the sentence.
Okay.
But everything else before that verb, it's a free-for-all.
The paper had that example, father gave me a book.
Ape anaku puttakam kotutar.
Right. But the paper says you can just scramble that. You can say, me father book gave, or book me father gave.
And they all mean roughly the same thing. There are nuances, but the core meaning holds.
See, that's where my brain breaks. If I'm a programmer, I can't just tell the computer, look at the first word to find the subject, because it might be second, it might be third. It's moving around.
Precisely. You can't rely on position. You have to rely on relationships. You have to look at the dependencies, how the words relate to each other no matter where they sit in the sentence.
And that's why this is called dependency parsing. It's trying to draw those invisible lines.
Yes, connecting the father to the giving, regardless of the word order.
Okay, but to test, if a computer can draw those lines, you need an answer key. You need a set of sentences where a human has already drawn the lines correctly.
And this is where we hit the reality of the situation back in 2011. For English, researchers have the Penn Tree Bank. It's a massive gold standard data set.
The Bible of English AI.
It really is. And for Tamil,
Let me guess. Nothing.
crickets. There was no such thing.
So what did they do? They couldn't just download a data set.
They had to build it. They went to a news website called Dynamani, scraped some articles, and started annotating everything by hand.
And when you say annotating, you mean?
I mean linguists looking at every single sentence and hand-drawing a tree structure, tagging every word with those complex codes we talked about. It is incredibly tedious work.
So how much did they actually manage to get done?
Well, this is the amazing part. They built a corpus of about 3,000 words.
3,000. That's it. I feel like I speak 3,000 words before my first coffee. How can you teach a computer an entire language with the equivalent of a pamphlet?
It is tiny. In the world of modern AI, 3,000 words is a rounding error. But that's what makes this paper so fascinating. It's a stress test. Can you get a machine to learn anything useful when the classroom is that empty?
Okay, so we have a super complex language and a tiny handmade data set. Now, let's meet the contestants. First up, the rule-based approach, the old school method.
This is the very logical approach. The idea is we, human beings, know the grammar rules of Tamil. We have textbooks. So why not just program those rules directly into the software?
It's like giving the computer a flowchart. If you see X, then you do Y.
Exactly. They used a framework called TectoMT. And they wrote a series of algorithms, just blocks of code, that try to deconstruct the sentence step by step.
So walk me through the logic. If I'm the rule-based computer, what's the first thing I do when I see a sentence?
Your first priority is to find the anchor, the main predicate. Since we know Tamil verbs are usually at the end and have those special tags, the rule is simple. Scan the sentence. Look for a word tagged as a finite verb.
And that's your root.
That's your root. Then you handle things like coordination.
Coordination, that's for lists, right? Like RAM and CETA.
Or ham and eggs, yeah. The programmers wrote patterns for this. In Tamil, and is often a suffix, so they wrote a rule. If you see a pattern like a, b, assume those two things are connected.
This actually sounds pretty solid to me. I mean, if the rules are true, the computer shouldn't make mistakes, right? It's just following orders.
In theory, yes, absolutely. But let's hold that thought, because now we have contender number 2, the corpus-based approach, the machine learning method.
This is the street smart approach. No rule book.
That's a great analogy. Here, you don't teach the computer any grammar. You don't tell it about suffixes or verbs or word order. You just take that tiny pile of 3,000 words, you feed it in, and you say, here are the sentences and here are the answers. You figure out the patterns.
That feels like a huge gamble.
Yeah.
You're asking it to guess the rules of a language based on a sample size that would fit on, what, a few sheets of paper?
It is a gamble. They split the data up. They used about 2,000 words to train it, to let it study. And then they kept about 950 words secret to test it with later.
2,000 words to learn syntax.
Yeah.
That's like trying to learn French by reading the back of a shampoo bottle.
It's an incredibly sparse classroom. They use 2 standard tools for this, Malt Parser and MST Parser. These are generic tools. They don't know Tamil, they just know statistics.
So fight night. Who won? The perfectionist scholar with the rule book or the street smart kid with the shampoo bottle?
Well, this is the really interesting part. Looking at the headline numbers, it was surprisingly close. Yeah, practically a tie. When they looked at unlabeled accuracy, which just means did you connect the right 2 words together, both approaches hit roughly 74%.
74%.
Oh.
Okay, that's a C grade. But considering the tiny data, that actually seems impressive for the machine learning side.
It is. And for labeled accuracy, where you have to actually name the relationship, like this is the subject, they both dropped to around 65%.
So they're neck and neck. But you mentioned earlier there was a catch, something about a gold standard.
This is the plot twist. And this is where the paper stops being just about Tamil and starts being about how AI actually works in the real world.
Okay, I'm ready. Lay it on me.
That 74% score for the rule-based system, That only happened when the researchers gave the computer a gold standard input.
Meaning what, exactly?
Meaning a human explicitly told the computer, this word is a noun, this word is a verb, this word is plural. The tags were perfect.
Wait, so the computer had a cheat sheet?
In a way, yes. It had perfect information to work with. But in the real world, you don't have a human linguist tagging every word you type into Google Translate. You have to use an automatic tagger, another piece of software, to guess the tags first.
And automatic taggers make mistakes.
They absolutely do. So the researchers ran the experiment again. But this time, they took away the cheat sheet. They used auto-POS, automatically generated tags.
And what happened to the rule-based system?
It crashed. The accuracy dropped from 79% all the way down to 61%.
Ouch. That is a massive fall. That's nearly 20 points.
And this reveals the fatal flaw of the rule-based approach. It's brittle. The rule says, find the word tagged as verb. But if the automatic tagger makes a mistake and calls it a noun, the rule doesn't know what to do.
It breaks.
It has a meltdown because the world isn't perfect.
Whereas the machine learning approach,
Yeah.
let me guess.
It barely cared. It performed almost exactly the same with the messy tags as it did with the perfect ones.
That is fascinating. So the street smart system, the corpus-based one, is just more resilient.
Infinitely more. It deals in probabilities, not absolutes. It sort of knows that data is messy. It knows that sometimes a noun looks like a verb. It just makes its best guess. And that ability to roll with the punches makes it so much more useful in the real world.
Okay, let's talk about where they struggled, because even the winner was only getting a C grade. What was stumping them?
Coordination was a big one, that and/or problem we talked about.
Why is and so hard? Can you give me an example?
Sure, think about the English sentence. I saw the man with the telescope and the dog.
Okay.
Well, did the man have both a telescope and a dog? Or did you see the man using a telescope and you also saw a separate dog?
Right.
Or maybe you saw a man holding a telescope and a dog was just standing next to him.
I see what you mean. The structure is ambiguous.
It is. And in Tamil, trying to apply the simple rules just fell apart when sentences got complicated. The rule-based system especially just couldn't figure out which words to group together.
There was another one that surprised me. Subjects. You'd think finding the doer of the sentence would be easy. John kicked the ball. John. Simple.
In English, yes. But in Tamil, the subject is often a ghost. It's not actually there.
A ghost. What do you mean?
Remember that zip file verb we talked about? Kotutar means he gave. The he is built right into the verb suffix. So in a sentence, you might not actually say the word he or father at all. You just say the verb.
So the computer is frantically looking for a noun to be the subject, but the subject is invisible.
Exactly. Or the sentence has 3 different nouns that all look like subjects, and the parser has to guess which one is the real actor and which one is just, hanging out.
I want to touch on one more technical term they use because it sounded very visual. Non-projectivity.
Yeah.
They said Tamil trees are often non-projective.
Right. So imagine drawing a sentence diagram. You write the words in a line at the bottom, then you draw arches above them to connect them.
Okay, I'm visualizing it.
In English, those arches almost never cross each other. They nest inside each other very neatly. That's called projective.
Nice and tidy.
But Tamil allows non-projective structures. Because of that free word order, the lines have to cross. The arch from word 1 to word 5 might cross right over the arch from word 3 to word 6.
Like tangled headphones in your pocket?
That's a perfect analogy. And mathematically, untangling headphones is way harder than just uncoiling a neat wire. This is where some of the specialized parsers, like MST parser, had a slight edge because they're designed to handle those tangles.
So, we have the results. The rule-based system is a fragile genius. The corpus-based system is a scrapper that just works with what it has. What's the big takeaway here?
The big takeaway is scalability and robustness. The authors basically conclude that writing rules is just too hard and too risky. It requires expert linguists, it takes years, and it breaks the moment you have one typo.
So don't write the grammar book.
Don't write the grammar book. Just annotate data, even if it's only 3,000 words. That small, messy pile of data gave them a 74% accuracy rate right out of the box.
That's a foothold.
It's a major foothold, and that is actually really encouraging. We always hear that AI needs big data, billions of parameters. But this proves you can get a functional start with a very small, high-quality effort.
It kind of democratizes the technology. You don't need Google's budget to start building tools for languages like Tamil or Swahili or Cherokee.
You just need a dedicated team to create that initial ground truth.
It's weirdly inspiring.
Yeah.
Imperfect data beats perfect theory.
In the messy world of human language. Every single time.
I want to leave everyone with a final thought on that coordination problem. The fact that a supercomputer struggles to understand A and B, it highlights something really fundamental about us.
Right.
When I say I'm going to get coffee and a donut, you know exactly what I mean. You don't run a statistical analysis.
You use context. You use common sense. You have a shared model of the world. You know that coffee and donuts are things that go together.
Right. We take that for granted. But we're essentially asking computers to decode our entire world just by looking at the order of our words. And as this paper showed, without that shared worldview, even a simple word like "and" can be a huge stumbling block.
It really shows we're still a long way from machines truly understanding anything. They're just getting really, really good at guessing.
So next time you see a weird translation on a menu or in an app, don't get mad. Just remember the invisible, tangled lines that poor computer is trying to untangle. Big thanks to the work of Ramasamy and Iopokritsky for this look under the hood.
It was a pleasure.
That's it for this deep dive. Thanks for listening, and we'll catch you next time.